All right. So we had one more topic to go over, and then we'll go through the review for the test. So if you looked at the review test, there's 6 questions, so it's not that long. Most of them actually are pretty quick. There's some that you have to do some calculations for, but most of them this test should not be as long as the last one. I will still be here at 9 o'clock on Thursday, so you guys can come in. As soon as you come in, you can start the test. And when you're done, you're done. So, and then you can go enjoy your wonderful spring break, which you're probably working during. So, all right. So we're going to talk about the binomial probability. When you think of binomial, what do you think of? Okay, so knowing parts of the word, what can come from it? 2. Bi means 2, right? So the key with this one is there's only 2 options. All right. So this only works when you basically have like a yes or no, or a true or false, or a win or a loss. You can't have like rolling a die and it's like, okay, the 1 comes up or the 3 comes up. That won't work. Heads or tails on a coin will work fine. You can do it with a die. It's like if you win if 1 comes up, that's fine. You lose every other time because then we're looking at the win-loss. The key with this one is the probability does not have to be 50-50. All right, the probability can change. So you can win more often or you can lose more often. It just depends on how you actually work with it. The formula, while it looks complex, I'm going to actually show you how to use Desmos to do this really easily. So remember what we talked about on Thursday last week? The N over the R is just the NCR. Okay? And then P is your probability. And it's raised to, I'm going to actually change those to R's, not X's. So we raise to the R, and then 1 minus P with the N minus the R. This is what this is going to give you is it's going to give you the probability that this number of events occurs. So say we wanted to find out what are the odds of me getting 5 heads out of 10 heads. So what are the odds of me getting 5 heads if I flip a coin 10 times? So what's the probability that I get heads normally? Right, so 0.50. So my probability is 0.50. So if you'll notice up here, I typed the entire formula in with the letters. And then all I'm going to do is down here, I'm going to fill in the numbers. So I said I'm flipping my coin 10 times, and I want 5 of them. About to be heads. So the probability that I get exactly 5 heads is approximately 0.25 or 25%. Would be the probability that I'm going to get exactly 5 heads if I flip the coin 10 times. That's not 5 or more. That's not 5 or less. That's exactly 5. Say I wanted exactly 4 heads. All I have to do is change my R to 4. That's the nice thing about using Desmos to do this formula. Once you type the formula in, you're just changing the numbers in it. Okay, you don't have to retype it all in to get the answer. Because what you're going to have to do is, for the problem on the test and the problem that we're going to do in a few minutes, you're going to look for a bunch of different options, and then you're going to be able to add and subtract to find out the ones you want. Okay. All right, so let's look at a problem. Whoever wrote this book really did have like a morbid sense of humor when they were writing problems. Because there's a lot of problems like this in this book. So the coordinate tables provided by the National Center for Health Statistics, there's roughly an 80% chance that a person the age of 20 will live to the age of 65. Okay. So, first question, is this a binomial? Is there only two options here? Because we have to decide that to decide if we could actually do this problem. Yes. Yeah. What are the two options? Yeah. All right. At 65, you're either alive or you're dead. Those are the two options. So because there's only two options, we can do the binomial distribution for this.
Mr. Baker,
Yes.
just a quick question.
Yep.
What did you show before you clicked on the mortality problem?
This?
Okay.
That was just a formula.
Okay, just asking.
No problem.
Thank you.
So this is my problem. So now we're going to go to my Desmos and we're going to type in the information that we have. So we have an 80% chance and we're looking at 3 people. Okay. So my probability is going to change to 80. My N, I've got 3 people. Okay. Now, when we're going to do this is we're going to look at, there's 4 possible choices that I can make. Okay. I can have nobody alive. I can have 1 person alive. I can have 2 persons alive, and I can have 3 people alive. We're going to look at all 4 of those options and get the probability for each one. So for 0, I type in R is 0. And there's a 0.008 chance. And now we change it to 1. So the probability that only 1 person is going to be alive out of those 3 is 0.096. So when we're looking, so you have an 80% chance to be alive. So the probability of 1 person being alive, that kind of makes sense. Like just under 10% chance, because there's an 80% chance that they're going to be alive. So now 2. So the probability of 2 people being alive, exactly 2 people being alive out of those 3, is 0.384% or 0.384.
Thank you.
And then the probability that all 3 will be alive is 0.512. Notice we haven't actually gone back and looked at what the questions were for this problem. But now we have all the different probability outcomes for this problem. We know what's the probability that nobody's going to be alive, 1 person going to be alive, 2 people are going to be alive, 3 people are going to be alive. Is there any overlap in those? Or are they all mutually exclusive? Exactly 0, exactly 1, exactly 2, exactly 3. Is there any overlap? No, because exactly 2 is just 2. Exactly 3 is just 3. So there's no overlap. So when we're looking for coming up with the probability of a range, I can just add them. That's why we did this. So now no matter which question I ask you, you can just add the ones you want and have the answer. Okay? So doing it this way first is faster because you get all the information you need, and then you can answer any question that I would want to ask. Okay? So let's go back to the question. So notice I just wrote down those 4 percentages that I had. I left them as decimals because it doesn't make much difference. All right, so question A. What's the probability that exactly 2 people will be alive? 0.384. That one's simple. We already had that one. So that would be if they wrote this as x equals 2. What's the probability that at most 1? So that's going to be written like that, less than or equal to 1. What do I have to do to find that one? At most 1. Which ones am I going to add together? 0 and 1. So 0.008 and 0.096. So I get 0.104. Because I'm just going to be adding the 0 and the 1, because that's what at most 1 stands for. At least 1. So that's the opposite. It's greater than or equal to 1. How did you get this number? Yeah, so you're going to add 1, 2, and 3 together, right? Is there another way I could have done it? You didn't have to add them all together, subtract 0. What's the total? 1. So I could have just done 1 minus 0, right? I could have just done the whole minus the 0.008. That would have given you the exact same thing. Okay? It doesn't matter. Either one's going to give you the same answer. Okay? It's just sometimes depending, like this one, there's only 4 options, but say there was 10 options. It becomes a little harder to sit there and add up 10 numbers than just to subtract off the 1. So both of them will come out to be the exact same, though in this case, it'll be 0.992. And also 1 minus 0.008, it's easier to do in your head than add 3 numbers together. So it doesn't make a difference. You would have gotten the same answer either way. Or you should have, at least, as long as you did your numbers right. Yeah, so not so the total probability when you add up all of them is going to be 1. That's the definition. So if everything occurs, you're going to have 1. It's 1. So I could have done not that one. I could have done 1 minus 0.00, and I got 0.992. Or I could have added the 1, the 2, the 3, those 3, and I would have gotten 0.992. Both of them would have come out to be the exact same thing. Like I said, this one, it's only 3 numbers you're adding. It's not that big of a deal. It's not going to be that much harder to do. But if it was a longer problem, it might be a little more complicated to do. All right. Any questions with this? All right. The key is using a calculator to get the answers. Like you could do it typing it out by hand, but it's much, much easier to use Desmos or a calculator. Yeah.
Is there something we could have the whole formula pop up where we have to?
You have to type it in. I just typed it in before class. But yeah, you can use any letters you want. It's just the key is making sure you're using the letters you know, like what they stand for. Like the problem uses X instead of R. It's fine. You'd have just changed X to R. But yeah, you just have to type it in, kind of. And then when you type it in, so basically what I did was I typed the formula in, and then you hit enter and you do P equals, N equals, and R equals on 3 separate lines, and then you can just type the numbers in that you want for those. And this works for any formulas. Like, say you had to figure out volume for something. You could type in V equals LWH and put L equals to W equals and H equals and type numbers in. It'll give you the formula for volume. This literally works for any single formula you could possibly think of. So it's a nice little use case for any math class, actually. All right. Just as with everything else, I have to be able to find mean and standard deviation. The nice thing about these situations is, since they're a binomial, there's a very specific way that it works. So we don't have to sit there and go through and do all these additions and multiplications and squaring and everything else to find out. All we would do is plug the numbers that we already have into the formula. In this case, it's just n and p. And those numbers they have to give you at the beginning of the formula. They can't, like, in the problem. They can't have you come up with those. So n will be the number that you were given, like how many people, or how many things, or how many events, and p will be the probability that that event occurs. So in this case, my n was 3, and my p was 0.80. So my mean is 3 times 0.80, or 2.4 people.
Wait, why do you have two means? Confused.
I don't have two means. I have one mean.
You wrote mean equals 3 times 0.80, and then mean is equal to 2.4.
That's what 3 times 0.80 is.
Oh, okay.
That's okay.
Sorry, my brain wasn't awake for a second there.
It's okay. It's early in the morning. So yeah, so if I had 3 people, the average would be that 2.4 people would be surviving. If I had, now obviously I'm not going to 0.4 per person, but we could look at it as, say I had 30 people. Okay. If I'm taking 30 people at the age of 20, how many of them would be alive on average by the age of 65? And the answer would be 24. Okay. Because I would just do 30 times 0.80. Standard deviation, same concept. I'm just going to plug in the numbers and do it out. So it's the square root. Now this one, obviously, I'm going to have to use a calculator for because I'm not going to be able to do this in my head. 0.80. 1 minus p is just the opposite of whatever the percent is. So if it's 0.80, 1 minus p will be 0.20. These two numbers right here, adding, should always equal 1 if you add those two numbers together.
They always equal to 1. Why even have it?
Because we're multiplying, not adding them. So if you were to add those two, you get 1. But we're multiplying. So that's why you need to have them. So I'm going to actually show you how to type this into Desmos. So you can see. So in this case, I do square root and p 1 minus p. And notice I already have n and p in the problem, so it automatically gives me my square root, or my standard deviation. So it's 0.69, 2 or 3. I said 3 decimal places.
So 3 is n, correct?
Yes,
And p, which is the success probability, would be
0.80 in this case. Yep.
Let me just label my formula so I'll remember.
So,
Thank you.
no problem. And like I said, one of the nice things about Desmos is I can easily just take this and say, let's look at a coin, 50%. And let's say we had 100 of them. The standard deviation would be 5 coins. Or if I had the mean in there, I should get 50 of them. That would be the average. So the nice thing is I can easily change. If we had a die and we were looking at a 1 out of the 6, it'd be 0.1667. If I was to roll 100 times, the sum should come up to be about, I'd have 16 of them approximately come up to be a 1. So the standard deviation is 3.7. So that's the thing you can start to do with this. Once you type the formulas in, you have everything there. As far as I know, there is no way to save your formulas in decimals. I know there is a way in the graphing calculator to do it, but I don't think they added a way in the scientific calculator to do it. No. Yeah, you can you can either download the app or you literally can go to the website and it's the exact same thing. So like you don't even necessarily have to download it. You can just go to your Chrome or Safari and go to the website. It'll be the exact same thing. Yeah. Yep. Nope. If I'm showing it to you, there's a reason I'm showing it to you to use it. Yeah. I'm like, I wouldn't show you something and say, nope, you can't use this. Sorry. That would be mean. Yeah. Start doing it all by hand. No, that's fine. All right. That's the only new topic I had to show you. So now let's review the test. What I'm going to do is I'm going to do this, the question 6, which is this topic first, and then I will go 1 through 5. I figured might as well do it that way since I just covered it. All right. So, according to the American Veterinary Medical Association, roughly 60% of U.S. households own 1 or more pets. 4 U.S. households are selected at random. I can't do 40 or 50 or 60, like a massive amount of, because then you'd have to do every single one of those. And that would be a pain in the butt to do. So that's why they're small numbers. All right. So what's my P in this situation? Yeah. So remember, change it to a decimal. So it's 0.60. And what's my N? 4 U.S. households. Okay. So now we're going to do R equals 0, 1, 2, 3, and 4. All right, so my suggestion would be, however you're going to do this on Thursday, try it right now. So this way I can fix anything if you don't understand how to do it. So whenever you do it, you should get 0.
I have a quick question. What does R represent?
2, 5, 6. How many you're choosing?
Like, what specifically are we choosing?
Well, in this case, I want to know the probability that I'm going to have 1 household. This is no households, 1 household, 2 households, 3 households, and 4 households. That's what you should get for 0 households. If you did not get that, tell me, and I will try to help you figure out how you get that. Oh, that's not a dot. It's always little bits. Make sure it's between the N and the R. It's a comma, not a dot. It's N comma R. Not a decimal. And then once you get to 0, it's easy. You're just going to change n to 1, write that number down, n to, or and not n, r to 1, r to 2, r to 3, so on. So you're going to hit the ABC button, and then you can actually put variables in. No, n is r. N, comma, r. Tap out. You raise to the power of r, yeah. And then just hit the AB button. No, that should be fine.
Okay. And then I just.
And then n equals r equals and
Yep.
b equals
Excuse me.
n r, n comma r. And then outside of it's p raised to the power of r. So you have to use the ABC button. A, B, yeah, A to the B button. That's correct. A, B will do it. I can type it in. And then you can put the R in it. And then you have to do the parentheses. So that put out put back down the whole thing, parentheses, 1 minus. And then raise to the n minus r.
How do you get to know what? how do you
Oh, you
get
have to NCR first. Here, I will show this. I was purposely not showing the answer. That's what the formula was. And you can use brackets, parentheses, that doesn't matter. But yes, the n and the n minus r has to be in parentheses, otherwise it will not let you put more than one thing in the exponent. So the n minus r has to be in parentheses. And the 1 minus p has to be.
So when I put everything in, like that word, is it this? It's on the graph. I typed in N.
Oh.
Obviously, because that's
Hold
why
on.
I also didn't see the parentheses. I was using like something else.
You're using brackets. Which is fine, but actually the mistake wasn't that. The mistake was a comment. Sure, quite. Yeah, actually. As you can actually make out. Yeah, you have to use parentheses.
All right, thank you.
No problem. Thanks. That's this one. Just this one. Let's see which one's on that. What's up on that one? We have to use that in this spot. That might make life easier. Might be new.
I think it might. Either the RVR, back over.
Oh,
And see. And then I can create a formula and take it out.
what do you mean?
Now I have to do 1 minus,
Yeah, so 1 minus.
it was just the parentheses.
Yeah, always use the parentheses.
Darn it. Thank you.
No problem. It just takes you to the scientific calculator for the statistics one. Like I thought, is they have most of the formulas built into this one for that. So
This is so cool.
it definitely makes life easier. Oh, first I have to hit NCR. And then you put the, and it's n comma r inside.
So if we have the page, the quote unquote page saved in our phone.
It's not going to save the formula.
I knew you said that. I didn't want to hear it.
Yeah, it's not going to save the formula.
Okay.
Because as soon as if you hit refresh, it'll clear it. I've tried, because what I've tried to do is I've tried to actually have it saved, like just the link and everything else, and then post it up so you could actually click on it and there's the formulas, but it doesn't work. The graphing calculator allows you, and actually, that might be the option, because I know you can actually type the formulas in the graphing calculator. I just thought of that. That would work. I might not have it done before. And then all you do is you go through and just change R and write down the answers. So you should get that. All right, so then it says, what's the problem? So then now that we have all that, we can answer our 3 questions. So exactly 3 is 0.3456.
On the test, you want us to write out the whole equation like that at the beginning, or you just say A equals B, 0.2456.
Oh, for this, no, oh wait, hold on, sorry. I was thinking 2 different things. This,
Yeah.
you do not have to write that down, no. I was thinking this part over here, and I'm like, yes, I do want to see that, otherwise I don't see your work. But then I'm like, wait, that wasn't what he was asking. So yeah, no, you don't have to write that down. I'm writing it down because if you look in the book and everything else, that's what you're going to see. And it also helps to get an idea of which direction you're going. Okay. So like where it says at least 3, sometimes people go, oh, that's less because least is less, but it's not. It's supposed to be 3, 4. It's supposed to be 3 and higher. At least 3 means you're going higher than that. So writing the greater than kind of clues you into that. So it says at least 3. So I'm going to add 3 and 4 together. So I get 6 plus 1, 2, 0.4752. And then at most 3, you can add up 0, 1, 2, and 3, or you can just do 1 minus 4. Either one of those will give you the same answer. 0.874. You should get that. So that's what I would be expecting for this question. And I'm not going to see your work, obviously, in the calculator, but writing down the 0, 1, 2, 3, 4 will give me that understanding of what you did. So, and that's actually, as it says, that's very important towards your points. Because if you screw this up, okay, that means you type something wrong in your calculator. Okay. But if you can get these right based on this, that means you understand at least how to like the variation of it. So that would get you points. If you just write down this with none of this and these are wrong, you get 0 points because I have no clue where you screwed up. Okay. So that's why it's really, really important to show me all your work. You'll get points based on that.
And also, how did you find B again?
It says at least 3, so I added 3 and 4. And then at most 3, you could add 0, 1, 2, and 3. I did 1 minus 4. I did 1 minus the 0.1296. But you can do it either direction. All right. Any question on binomial probability? Okay. So let's look at the other questions. So this is the question. It says use the table below of AGI to answer the following questions. What's the probability of returning having under 10,000? And there's a bunch of basic questions on this one from that. You'll then have the table of values next to it. Now, what I would, again, just like the last problem for me just showing your work, fill in the probability for each one and then answer the questions. Okay? So we're going to take this table here. First thing we're going to do is find the probability of each of those events. How do I find the probability of each of those events? Well, how would I find the probability of A? Yeah, so I'm going to take the 26,268 divided by, and they already added them up for you. That now I caught what you're saying. The 142,450. Yes, they're already going to give you that, so you don't have to add them up. So we're just going to divide each of those and get the answers there. So for the first one, I get 0.184. And remember, go to the 3 decimal places for each of these. And actually, all I did was just like I was doing before. I just did it and then just changed the X. Instead of having to click back in here and trying to change that, it's easier to change that. So, like, these are the little tricks and stuff that aren't going to help you get the answer right necessarily, but they're going to help save you time. And a lot of times, the biggest stress that comes in on taking a test is that time factor. It's like, you have to be done at a certain time. You don't have an unlimited amount of time. So it's like sometimes being able to save a few seconds here and there, or like on that, it's really easy to click in the wrong, like touch in the wrong spot on your phone. And you end up deleting a number that you didn't, and then you have to type the whole thing back in. So it's like those little things save you time and aggravation. So, all right. Now, the nice thing about having all that is now it's really easy to answer your questions because all you're going to do is add and subtract the things you want. Okay. So, what's the probability of having a return under 10,000? 184. Okay. What's the probability of having an AGI greater than 30,000 but less than 100,000? So now we're going to add up greater than 30. So this one, so we're going to add the 0.102, the 0.079, and the 0.217. We would just add those three together. Because that's greater than 30, but less than 100,000. What's the probability of getting an AGI not being greater than 100,000? Yeah, we would take, you could do, like, this is one of those ones that I would not add them all up. I would just subtract off the 1 over 100,000. So it'd be 1 minus the 0.128. Okay? Because adding the other numbers is going to take you a lot longer because there's a bunch of them. All right, so the last two are a little trickier. All right, so it says if event H shows the AGI between 20 and 100, and event I shows AGI less than 50, what's the probability of H and I? So H is from 20 to 100, and I is under 50. So what would H and I be? So remember, and means they both have to work, right? So which ones am I looking at in this situation? So we're looking at, since it's and, we're looking at the overlap, correct? So H is from 20 to 100, and 50 is from 50 all the way down to 0, basically, right? So where's the overlap? The overlap starts at 20 and goes to 50. Okay? So I'm going to be looking at the 20 to the 50 for this one. So really question D and E is asking you for me to understand if you understand what and or means. Okay? Once you get that, then you can add up the values correctly. So in this case, we would be doing that one, and that one. We'd add up C, D, and E. What if it's H or I? Now we want everything, right? So H or I has to start at 0 and go all the way to 100. So in this case, it's actually the exact same thing as saying less than 100, which we already did. So in this case, we'd be adding up anything less than 100. Okay, so D and E is asking me to make sure you understand and or. Question one's worth 25 points. So basically, every question's worth about 5 points. All right, next one. So the next one is using a probability table. That's a conditional probability table. It's got the different things in it. So using the following table of age and living arrangements to answer the following questions. Okay, so this is the one where we're going to have those conditional probabilities. So you have to look at what the question's asking you, comparing it to the thing. The first couple of questions are just asking you. It's straight in of the whole thing. Okay, D and E are those conditional probabilities. Notice the word given. That word in there means it's a conditional probability. Okay. So, first question was, what's the probability that a person selected is living with a spouse? So, living with a spouse, they gave you the totals already. The totals are here and here. So, the probability that somebody's living with a spouse is 0.500, 50%. Now, you can give it to me either way. You can give it to me as just the decimal, or you can give it to me as a percent. It doesn't make a difference. They're both probability. What is the probability that a person selected is over 64? 0.158. What is the probability that a person selected lives with a spouse and is over 64?
0.088.
0.088. Okay. So notice none of those questions had the word given in them. So they are not conditional. They're just the percentages that are on there. D, what is the probability that a person selected lives with a spouse given they're over 64? So, given matters. Given's going to tell you what the bottom number is. So in this situation, we're going to take that 0.88 and divide it not just take that number, we're going to divide that number by if they are over 64, which in this case is 0.15. Okay? So for this one, I'd have done that divided by that. So what was this question? Was it D? D. So D is 0.088 divided by 0.158. It can never be over 1, so if you swapped it, you know you did something wrong. Which comes out to be 0.557. The next question says, what's the probability that person selected is over 64, given they live with a spouse? These two questions sound the same. The given switched though. The given's telling you what the bottom is going to be. So since this one is, what's the probability that they're 64, given they live with a spouse? I'm now taking that and dividing it by the 0.0500. So it's going to be 0.088 divided by 0.500. It comes out to be 0.176. So that's what changes. The given is always going to be your bottom piece. Okay? All right. Next question. In the United States, telephone numbers consist of a 3-digit area code followed by a 7-digit local number. They're broken up into 3s and 4s because we remember things better when they're in groups of 3 and 4. That's why phone numbers and social security numbers are basically broken down like that. Suppose neither first digit of the area code or the first digit of the local number can be 0. But all of the choices are accessible. How many different area codes are possible? So just for the area code, the first digit, how many numbers can be there? 9, not 10 because the 0 doesn't work. How many numbers can be in the second one? Huh? Nope. 10. Because it doesn't say anything about repeating. So the numbers can repeat. If it said the numbers could not repeat, it would be 9 again because I would accept the 0 now, but not the first number. And then the last number would also be 10. So there is a total of 900 area codes. Now it says for a given area code, how many local telephone numbers are there? So we're not looking at the area code. We're just looking at the local number. There's 7 digits. The first one cannot be 0. But everything else after that can be anything. So in this case, I have what? The first number is going to be 9. Because I could still have 1, 2, 3, 4, 5, 6, 7, 8, 9. I just can't have the 0. The second number can be any number from 0 to 9. So that would be 10. Where you were getting the 6 from, I'm going to have 7 numbers. So
Gotcha.
I'm going to have this 7 times. So that's the first 3 and then the last 4. So I would have 9, 1, 2, 3, 4, 5, 6, 9 million. Different phone numbers. How many different phone numbers are possible? You do not have to go through and do the whole thing out again. You can just multiply those 2 numbers that you have. So it's 900 times 9 million, which is 81. And then 1, 2, 3, 4, 5, 6, 7, 8. So my commas are in the wrong spot. But so 8,100,000,000 phone numbers.
Eight zero.
Yeah, it should be 8 zeros. 6 plus 2.
Comma.
I'm not worried about the commas. If you don't put the commas in your answer, it's fine. But that's also, again, that's where showing your work's important. So like, say you put down the 900 and you miss a 0 in the thing. I know you just missed a 0. Like you had the right concept. You just miswriting it in a zero. That happens. I'm not going to take all the points away for that. Yes.
How did you get the 9 times 10 times 10 for A?
Because it said there can be, the first digit cannot be zero.
First digit cannot be 0.
So all the numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers. The second number can be anything. So it can be 0 through 9. So there's 10 numbers. And the third digit can be anything. So there's 0 through 9. Yeah.
I can visualize. Call my friend Colorado or
Yeah.
California or Texas right now.
Okay, so second number can be anything 0 to 9.
Mm-hmm.
And then third digit, like you said,
Can be anything again from 0 to 9. That's why there's 10.
Okay.
And obviously there's area codes that would not exist just because, like, you're not going to have 911 as an area code. That would be bad. All right. So, like, there's things like that. So there's only there's restrictions on that. And actually the problem that you're going to have on the test is similar, but I added some more restrictions to it. So it's the phone numbers in Bakeropolis. All right. So, an investment firms usually have a large number of selection of mutual funds from an investor can choose. One such firm has 30 mutual funds. Suppose you plan to invest in 4 of these mutual funds, one during each quarter of the next year. And how many different ways can you make these 4 investments? This is a question of does order matter or does order not matter? Okay, because remember that's really the question here. So it's NCR if order doesn't matter. And it's NPR if order matters. So in this case, my N is 30 and my R is how many am I choosing? 4, right? So is it NCR or NPR? Does order matter?
No.
It does matter, it doesn't matter.
Doesn't.
It does not
Doesn't?
matter.
Okay. I think you said it does.
I said it does because it says 1 per quarter. But are we looking for the?
Actually, you're right. And that's the key words right there. 1 per quarter. So think about an investment, right? When you invest, does it matter? Yes, because you're going to, depending on how it does during that time, right? So time matters when you're dealing with investment. So in this case, order matters. Okay. Now, if you were to guess that wrong, but you did the problem correctly after that point, and you said order doesn't matter, you used NCR for this one, you would not lose all 6 points. I may take a couple points off because you got that piece wrong, but you still did the process after that correctly to get the right answer, or at least that answer. So in this case, order matters because I'm going to invest 1 first quarter, second quarter, third quarter, fourth quarter. So that time changes. So whichever one I invest in first, I'm going to make the money off of that for a longer period of time. So order does matter in this situation. So this is going to be a P. So it's 30 P4. So we're going to go to the calculator. We're going to use NPR. And it's 30, 4. And there's 657,720 different ways I can choose out of this. Okay, and that's it for that question. All right, last question. An office has 6 incoming phone lines. The probability distribution of number of busy lines are as follows. So they're going to give you all the probabilities. A, what's the probability of 4 lines being busy?
0.174.
Yep, this is there. What's the probability between 2 and 4 lines being busy?
0.646.
So we're going to add those 3 together. What did you get?
0.646. From
Okay.
adding the 2, 3, and 4 lines.
Okay, I'm going to trust you. I didn't do it. So,
Okay.
all right, so you're just going to add those. Notice it says inclusively. That means you're adding the 2 and the 4. If it said just between 2 and 4 and it didn't actually have that there, technically the answer is 3. It's 0.240. Okay, because between them would be just between them, not adding the endpoints. So it will have inclusively on the test too. So don't worry about that part of it. Okay. All right. Now, on average, how many lines are busy? This is where you have to find your mean. This is just like doing a weighted mean. Okay. You're going to take and multiply each of these together and then add them up. I will tell you right now, this 15 points is not 5, 5, and 5. Okay. This question, C is going to be worth more because there's more work for there. So you're going to take 0 times that, and you get 0. 1 times that, 1.54. 2 times that, 464. 3 times that, 720. Yeah, now I'm getting. So we'll do this one. 525. Like some of them I could quickly do in my head, some I cannot. Six. It just depends on if there's the carrying and stuff like that, like when you're trying to do those carrying and stuff like that in your head. Two, five, eight. So to find the mean, they multiply each column and then add up the answers for this one. Or it could be multiply each row depending on how it's done. So then we're just going to add up all those answers. So I get 2.817. Lines are busy. And again, this is where showing out your work and writing those numbers down is helpful. So like if you did some of them right, but you got like one of them wrong and you're off by a point, but then you added those up, your mean's probably going to be off, but I understand why your mean was off. Okay. So show me all your work. You guys did a decent job of that in the last test too. So it's like, but I just know how easy it is when you're doing work on a calculator to just not necessarily write every number down, just have them in your calculator and then just add them up, but write them down. So this way, if you do make a mistake, it's easy for me to figure out where you made it. So. Okay. You are allowed an index card, just as last time. I will be here at 9, so you can come in early to start your test. This will be up there. The review test is already up online. I'm sorry, for some strange reason, when I posted it last time, it saved my edit after I posted the video as a draft. So that's why it wasn't there right away, but it is there now as if they're Sunday. As a couple of people yelled at me, but it's fine. You're allowed. So the review test is there, so you can go through and look at it and decide what you're going to put on your next card. Other than that, any other questions? Okay, I will see you on Thursday.